Let's pray. In the name of the Father, Son, Holy Spirit. Amen. Lord, we submit this meeting to you today. Own it, guide it, and make it a successful meeting, a pre-event meeting for the Mumbai conference in November, December of 2023. And we thank you for having enabled us to meet today. Continue, Lord, facilitating all those that have not joined, and bless the technology so that technology favors us. For all things belong to you, we belong to you, and we thank you for everything. And in Jesus' name we pray. Amen.
Amen.
Good.
Okay. Should we get started? A very good morning from Kenya and a very good afternoon from India. Welcome all the participants to the Kenya East Africa India International Collaborative Virtual Conference on Waste Management and Circular Economy. We are organizing this conference as part of the World Day celebration. This is a pre-event of the 13th International Conference on Sustainable Waste Management and Circular Economy and the IPLA Global Forum 2023, which is organized by the International Society of Waste Management, Air and Water in Kolkata, India. I am Jeremy Munene Kaburu, Associate Researcher and member of the country-specific working group in Kenya of the 13th International Conference on Sustainable Waste Management and Circular Economy of the International Society of Waste Management, Air and Water in India. Today, I share the responsibility of coordinating this program along with my fellow coordinators, Padma Gunde, Juliana Mwanya, Gilbert Mutai, Charles Karaoke, Dinesh Kumar, and Dr. Ispita Shah. Mr. Dinesh Kumar, a research scholar at Jandapur University, will be managing the recording and the online platform. At the onset, I would like to remind all our participants to keep your mics in mute mode and not to speak or share your cameras until you ask to do so. The speakers are requested to adhere to their time strictly. I now invite Ms. Padma Gunde to share a brief about the International Society of Waste Management, Air and Water.
Good morning, everyone. This is Padma Gunde. I am co-founder of Ecofy Services LLP, and I'm also a member of ISWMAW Hyderabad. Now I would like to brief about ISWMAW. International Society of Waste Management, Air and Water, ISWMAW, was established in 2009 in India by Professor Sadan Ghosh for betterment of waste management and environment protection by promoting 3R and circular economy concepts having involvement and participation of 50 countries across the world and most of the states in India. Problem of waste management primarily lies in poor segregation of waste and governance. ICON SWM involves in spreading awareness, carrying out of research and implementation activities in the area related to waste management worldwide. It promotes environmentally sound waste management practices, effluent treatment, air and water pollution control practices, and general environment protection awareness in different parts of the country and abroad. ICON SWM and ISWMAW research and other activities involves international collaborative research projects 2018 and 2024, global status of circular economy and implementation with 25 country experts, including UNCRD, research projects at different institutes, namely IISc Bangalore, Jadavpur University, and in other organizations in West Bengal, Karnataka, and other parts of the country. Now, the 13th International Conference on Sustainable Waste Management, Circular Economy and IPLA Global Forum will be held at KG Somaya Institute of Management, Mumbai, from November 29th to December 2nd, 2023. So please submit your abstracts by 30th June 2023 and full papers by 30th August 2023. So that's a brief about ICON SWM and the conference, international conference being held in November. I now hand over my microphone to Juliana Monia to proceed forward. Thank you. Juliana, can you please take over?
All right. If Juliana has some problem, Jeremy, you take over that. Jeremy, you can start Juliana's part.
Okay. I'm going to share about the objectives of the conference. The objective of this conference are to spread awareness on waste management, circular economy, and decarbonization, as these three aspects will help in achieving Sustainable Development Goals 2030. Two, to bring people across the world together to act together for the cause of environmental protection and encourage in related research. The third objective is to bring all stakeholders together under the umbrella of the International Conference on Sustainable Waste Management and Circular Economy, a worldwide movement. And fourth, it's ultimately to educate the people in beating the plastic pollution and get benefit out of the resources generally from the end of life of materials. Today's program is divided into 5 sessions: inaugural session, 1 keynote session, 2 technical sessions, followed by a concluding session. The keynote session is for 15 minutes, and the rest of the presentation in the technical session are for 10 minutes. Speakers will be reminded of the 2 minutes before finishing, and once more when the time is up. All the speakers are requested to maintain their time schedule strictly. Participants can type their question in the chat box, and those that will be taken up at the end of the session. Coordinators will read out the questions from the chat box. I request chairs and co-chairs to briefly summarize the sessions in 5 minutes. Again, I remind all our participants to keep your mics in mute mode and not to speak or share your cameras until asked to do so. I now hand over the microphone to Charles Karaoke to coordinate the inaugural session.
Hello, everyone. I welcome you to this inaugural session. My name is Charles Karaoke, and I will be your coordinator for this session. Now, each speaker has 5 minutes to deliver their speech. Now, the speakers are kindly reminded to adhere to the allocated time. You will be reminded about the time when 2 minutes are left and when the time is up, so that you can wind up your speech. Now, to begin this session, I wish to invite Ambassador Professor Michael Koech to deliver his welcome speech. Ambassador Professor Koech is an associate professor in the Department of Environmental Sciences and Education in the School of Agriculture and Environmental Sciences at Kenyatta University in Kenya. He is the founding Director General of Kenya's National Environment Management Authority, that's NEMA. Professor Koech also served as a permanent representative of Kenya to the United Nations Environment Program, that's UNEP, from the year 2000 to the year 2002. His research interests are in environmental education and sustainability, ecological studies, environmental management, and policy development. I now request Ambassador Professor Koech to give his welcome speech. Please unmute and share your camera. Professor.
Yeah, thank you for that introduction. And before I share my welcoming remarks, I would like to thank God for enabling us individually and collectively to plan, organize, and through the virtual meetings that we have had so many times, and implementing our collective effort this morning. We thank God for all of this and the more plans that God has given us for the future. So good morning, everybody. My name is Michael Koech from Kenyatta University, and I would like to extend a very warm welcome to all the esteemed academicians and the experts from various parts of the world to this African pre-event of the 13th International Conference on Sustainable Development and Waste Management and Circular Economy, and the International Partnership for Expanding Waste Management Services of Local Authorities. And I am honored to commence or to start this meeting or this forum as we look forward to sharing and comparing various important matters concerning sustainable development, sustainable waste management, and the circular economy. Firstly, I would like to thank the adept organizers of this conference for laying down the groundwork which paved way for this conference to kick off here in Kenya this morning. Secondly, I would like to thank all the participants, the contributors, and the speakers from various professional backgrounds to agree to take part in this conference where we converge and share our ideas and views and subsequently implement them. We are pleased to have you join us and participate in this meeting. Today, we highlight the areas of solid waste management, circular economy, and sustainable development. These discussion topics are important to keep deliberating on and conducting research on so as to have data that continue to contribute positively to our work as experts, academicians, policymakers, at the national, regional, and global arena. It is no doubt that how we approach waste management and resources management will significantly contribute to sustainable development and climate change mitigation and adaptation measures. And you may recall, for those who attended the COP27 held in Egypt in 2022, and I participated virtually, and a number of issues were discussed, including waste management, were really identified as an area that need to be addressed, and also reducing waste generation, promoting environmentally sound waste management, controlling transboundary movement of hazardous and illegal wastes were identified as important for all countries to address them and to meet their commitments. It was also stated that the area of waste contribute to 10% of greenhouse gases or gas emissions, where 31% of this is contributed by open dumping, with some lower income nations relying on these, totaling to around 93% of their disposal method. Waste ends up in public ecosystems. Illegal landfills are burned openly and cause a lot of pollution. Additionally, the COVID-19 also brought its own problems, and many hazardous wastes have been dumped around globally and in various regions. Recently, I was reading in the social media that some market and social research company is about to start a research of solid waste management in Rwanda. The research will take about 12 months. And the advert said, those who are going to be hired for this job must all have university degree, a bachelor's degree with the following fields covered: waste management, environmental engineering, environmental economics, business administration, finance, and last but not least, circular economy, which is one of the topics of this meeting today. Now, today we have approximately approximate population of 1.4 billion people in India and 1.4 billion people in the continent of Africa, and the challenges faced with regard to environmental sustainability in the subcontinent of India and the continent of Africa, and are not very different. They are all the same. Some of the challenges include the generation of waste from an ever-growing population, as we know, more so in urban areas, and the transportation of these wastes, the treatment and disposal of the waste. Some of the presentation during this conference will highlight some of these issues and realities faced in two parts of the world, and we reflect them as we ask ourselves a number of questions as policymakers. One, do we have enough information available to the masses? Do we have clear laws and guidance in our societies or our nations? Do nations and agencies coordinate effectively across the nations? What is the state of our monitoring and enforcement and mechanism of all that we do in order to manage waste? Those are the questions we need to ask, and those are the questions that we are addressing in this meeting and will help us to move forward. As we reflect on these and other questions, we are also reminded that we are tasked to make positive marks on this world and aim to steer the globe towards sustainability. We need to have capability of making our globe a sustainable habitat for all living mechanisms to coexist. And we must not give up. We must continue. And all the efforts that we make are very critical. And before I conclude my remarks this morning, I would like to say that there is a proverb that says a journey of 1,000 miles starts with one step. Professor Ghosh and I started that one step in a solid waste conference in Maryland in the US in March of 2018. And then he invited me to a physical conference in India in November 2018. And Kenyatta University supported me in attending that conference. And I contributed, and I was very pleased. I learned a lot, even in the field trip that we had, and we saw how India manages their waste and how they coordinate them. It was a very successful conference. I then recruited Jeremy Kaburu, who is in this meeting today. Jeremy Kaburu recruited Desmond Situma, and we became 3. And later on, we recruited Mrs. Mary Kinoti, and we became a group of 4. And that group of 4 has made a lot of efforts, has recruited many of us that are attending this meeting today and contributing to this meeting. And Mrs. Mary Kinoti comes from the University of Nairobi. And I just want to say that this group has facilitated, has elaborated, has recruited, and in conclusion, I want to say that small is beautiful. A number of years ago, I read a book, an economic book, many years ago that was entitled Small is Beautiful, and it is effective, and it is blessed, and it's also opened doors and opportunities to all of us locally and globally. And I believe this conference will do that, and it will open doors and opportunities for us to participate in contributing effectively in the management of waste management and circular economy as we do this. And concluding, once again, it is a great pleasure to welcome you all to this conference and look forward to the discussions and the deliberations. And at this point, I would like to hand over to Professor Ghosh to guide us through the next steps, or the coordinator to guide us in the next step of this conference. Again, thank you all. Thank you.
Thank you, Professor, for that wonderful welcome speech. You may mute. I now request Professor Sadan Kumar Ghosh, the President of the International Society of Waste Management, Air and Water, India, to speak about the collaboration. Professor Sadan,
Thank you.
please
Thank you,
unmute and share
Charles.
your camera.
Thank you, Charles. And thanks, Professor Quech. It's my pleasure to be here with quite a good number of people from different countries. I can see here the people from Kenya, Norway, South Africa, Ghana, India, and some other countries I cannot remember from here. So however, at the very outset, I must mention few names through which I mean collaboration. Dr. Kare Hegle Karstensen, he is my collaborator in Norway. Dr. Kulwant Singh, he is my collaborator in India, North India. Mr. CRC Mahanti, he is my collaborator in UNCRD, Japan. Mr. Diviz Rao, he is my collaborator in India from Vizag, from the industry. Mr. M. Birachari, he is my collaborator from industry, waste to energy industry in India. Mr. Satish Kamath, he is my collaborator from India on the South India, and he is he's operating a very big business estate, or he will explain later on. And you know that in this way, I can see one more friend we are missing is Dr. Raman Ramchandran, whose representative is here, Dr. Satyendra Upadhyay from KJ Somaya Institute of Management. So you know that, and the last but not the least and very important is Professor Michael Quech from Kenya. So you know, this is the way we are expanding our collaboration with respect to research, with respect to publication, with respect to collaboration in industrial activities, and with respect to personal friendship. So this platform we are utilizing for making collaboration on the research project, for development of the global initiatives on sustainable development, sustainable environment, environmental protection, waste management, circular economy, decarbonization. And there is a need for personal relation in different countries. So today, the International Society of Waste Management, Air and Water, and also the ICON SWM, International Conference on Sustainable Waste Management and Circular Economy, it has 48 country-specific working groups who are working for the sustainability and for the success of this collaborative conference. I am very happy today that the whole team, I missed here that my friends from Uganda and also South Africa are here. They will be also speaking. So I am very happy, and I must mention that the team in Kenya, led by Professor Michael Quech, have done a great job for this conference, and they will also working as a country-specific working group in ICON SWM. My team from India, like Padma, Sutripta, Ifshita, and other friends, they also did a wonderful job for this program. So what we want is, we will have 2 special sessions on collaboration between among different countries and African countries. So I wish that my African friends from different countries will make these 2 sessions in ICON SWM a grand success, which will continue for 90 plus 90, around 180 or 200 minutes. So I'll be giving the responsibility to my friend, Professor Michael Quech, to coordinate, and also my friends from South Africa and Uganda. So with this, I must thank all of you for your presence here, and to encourage your presence will definitely encourage the whole team of the African countries and India. With this, I must thank once again and thank you very much. I'm handing over the microphone to the coordinator. Charles.
Thank you, Prof, for that insight there. At this juncture, I wish to invite Mr. M. Viracheri to talk about the 13th International Conference on Sustainable Waste Management and Circular Economy and IPLA GF 2023. Mr. Viracheri is the president of Andhra Pradesh Operations and Projects, Jindal Urban Waste Management Limited, and AP India. He has 34 years experience in iron ore, steel, cement, power, waste to energy sectors, as well as academics. He executed 52 green and brown field projects. He executed 3 waste to energy projects as part of his research. He worked with several organizations in India and other countries and provided technical support for various projects. He is a member in the Expert Advisory Committee for Waste to Energy Technology in the Department of Science and Technology of the Government of India. He is also the Vice Chairman of the International Society of Waste Management, Air and Water. I kindly request Mr. Viracheri to deliver his speech. Please unmute and share your camera. You have 7 minutes to deliver your speech.
Thank you very much, Mr. Charles. And also, I am very thankful to Mr. Sadhan Ghosh and also Engagement Services of local authority. Now, I am sharing my screen where it explains the objectives of International Solid Waste Management of Society for Water and Air. Please share the screen. Presentation. The objectives of International Society of Waste Management of Air and Water is solution to municipal solid waste, agriculture waste, construction and demolition waste, biomedical waste, industrial waste, plastic waste, e-waste, sewage water, and the motto is protection of environment by air and water. Next. A case study of solution to municipal solid waste, where we are presently operating the industry. Jindal is operating at 4 places. Next. The waste generation in the world, around about 2.24 billion tons of solid waste, amounting a footprint of 7.9 kilograms per person per day, and with rapid population growth and urbanization, annual waste generation is expected to increase by 73% from 2020 levels to 3.88 billion tons in 2050. Next. The waste scenario in India, it is explained here. In India, the per capita generation in rural areas is 200 grams and urban areas is 500 grams, whereas the international standard as per United Nations is 1000 grams. And the projected municipal solid waste generation by 2031 in India is 185 million tons per annum. Next. In other countries, now we are focusing on Africa. We are speaking about Africa. The generation 125 million tons of municipal solid waste was generated in Africa in 2012, which is expected to be doubled by 2025. The disposal, more than 90% of waste generated in Africa is disposed to uncontrolled dumps and landfills, often associated with open burning, which is highly hazardous. 19 of world 50 biggest dumps are located in Africa, all in sub-Saharan Africa. So this is an important forum for all the African nations to join with this International Society of Solid Waste Management of Work and Water. Next. The impact of dump. If you dump 1 ton of this MSW, municipal solid waste, the methane generation is 150 kg and carbon dioxide is 2000 kg, and land required is 2480 hectares per year per 10 meters height, and this methane is 21 times more dangerous than the carbon dioxide. Whenever the raining happens, the dump will be wetted and the water seeps into the groundwater. That is called leachate. The BOD, COD, and TDS has explained clearly here against the limits. The leachate pollutes the groundwater for decades together. Next. The global scenario of waste energy plants: in China, 900 plants, Europe, 500 plants, America, 84 plants, Latin America, 4 plants, Japan, more than 400 plants, Singapore is a small country, 4 plants are there, India, 10 plants are there, and India also needed a lot of work to be done, more than 300 plants. The first incineration plant at Netherlands in the year of 1937, and first great incineration plant successfully operated at Japan in the 1965 year. And solid waste management rules framed in Japan in the year 1900, whereas in India it is 2000. It is very unfortunate. And we are also having less land mass and more population. Next. We have checked different technologies like gasification, pyrolysis, plasma, and all the things. But ultimately, in Japan, we have taken as a case study, 84% of the plant of Japan municipal solid waste is handled by mass incineration through great combustion. Next. These mass incineration plants are very friendly in nature. We have given the Indian norms of 2016 solid waste management rules, international standards, and presently Jindal Urban Waste Management Guntur Limited, Jindal Urban Waste Management Visakhapatnam Limited is thoroughly explained like this. Next. This is the scenario in Tokyo, where in the city of Tokyo, 21 plants are operated in the city center, but no pollution at all. Next. This is the waste to energy plant near to Eiffel Tower, which is the most famous tourist place in Paris. Next. The cleanest city in the world is Zurich, where this waste to energy plant is located in the center of the city. Next. This is all about this one. Now I am presenting the plant video. Please see the plant video. Yeah, it will.
Can you hear me, Mr. Birachari?
Yes.
Yeah, so as Dr. Kare has a flight and he has to leave within 10 minutes. So what I'll request you, please stop this. Once Dr. Kare, listen, once Dr. Kare finish it, and then we will see this video.
No, kindly allow me, please.
Birachari, we will allow you, but after Dr. Kare finishes, because he has to leave for his flight. All right, we will allow you, but after Dr.
Opposite.
Charles, where are you? Hello, Charles.
I'm here, Prof. Yes.
Go
So,
ahead. Go ahead. Please.
so we can proceed. We thank Mr. Virachari very much for that beautiful presentation. It is now my honor to welcome Dr. Kari H. Karstensen to deliver his inaugural speech. Dr. Kari is a senior scientist at SINTEF, Norway, and a co-chair of the 13th International Conference on Sustainable Waste Management and Circular Economy 2023. He has over 30 years of research and management experience at various levels. He is recognized as one of the pioneers of co-processing and treatment of wastes in resource and energy-intensive industries. He has published crucial research and development findings and developed regulatory frameworks and guidelines on co-processing for multiple governments, UN bodies, and international organizations. He played a key role in introducing co-processing in several Asian countries. He successfully executed challenging projects for governments, international organizations, and leading industries. He has authored over 100 peer-reviewed publications, books, and scientific reports. He is initiating and implementing capacity building and performance enhancing sustainability projects in developing countries. I request Dr. Kari to give his inaugural speech.
Thank you very much, Charles. Distinguished guests, ladies and gentlemen, it's an honor for me to, present this inaugural speech from Oslo, Norway. And I really hope this conference, very important conference, is going to be successful because our world faces significant challenges and it is our responsibility to address them with urgency and foresight. One of the most pressing issues that demands our attention is waste management and the imperative need to transition towards a circular economy. We live in a time when our planet is grappling with consequences of excessive consumption and a linear approach to resource utilization. The traditional take and make dispose model is not sustainable in the long run. Our precious resources are being depleted at an alarming rate, while landfills continue to overflow, polluting our air, water, and soil. And this path is simply untenable. However, amidst these challenges lies an opportunity to reshape our economy and build a more sustainable future. The concept of circular economy provides a powerful framework for achieving this transformation. A circular economy aims to minimize waste, keep products and materials in use for as long as possible, and regenerate natural systems. It is an economy that works in harmony with nature, creating a closed-loop system where resources are used efficiently and waste is minimized. To embark on this transformative journey, we must adopt a multifaceted approach. Firstly, we must prioritize waste prevention and reduction, and this requires a shift in mindset where we value durability, repairability, and reusability over disposability. By designing product with circularity in mind, and promoting responsible consumption patterns, we can significantly reduce the amount of waste generated in the first place. Secondly, we must embrace recycling and reprocessing as an integral component of our waste management strategy. Recycling allows us to recover valuable materials from waste and reintroduce them into the production cycle. We need to invest in infrastructure, technology, and research to optimize recycling processes, improve collection systems, and create markets for recycled materials. By doing so, we can reduce our dependence on virgin resources and curb the environmental impact associated with extraction and manufacturing. Furthermore, we must encourage innovation and collaboration. Governments, businesses, academia, and civil society must work hand in hand to develop and implement sustainable solutions. We should incentivize research and development in areas such as advanced recycling technologies, renewable energy, and eco-friendly materials. By fostering a culture of innovation and knowledge exchange, we can unlock new opportunities and drive the transition towards a circular economy. Equally important is the need for education and awareness. We must empower individuals and communities with the knowledge and tools to make informed choices and take responsible actions. Environmental education should be integrated in our educational system, highlighting the importance of waste reduction, recycling, and sustainable practices. By nurturing a sense of environmental stewardship, we can cultivate a generation that understands the value of our natural resources and the urgency of protecting them. As we embark on this journey towards a circular economy, we must also address the social dimension. We must ensure a just and inclusive transition when no one is left behind. We need to create jobs and provide training and reskilling opportunities for workers affected by the shift away from traditional industries. By prioritizing social equity and empowering communities, we can build a more resilient and sustainable society for all. In conclusion, the challenges we faced in waste management and the transition to circular economy are formidable. However, they also represent a turning point, a chance to reshape our future and leave a positive legacy for generations to come. Let us embrace this opportunity with determination, creativity, and collaboration. Together, we can build a world where waste become a thing of the past and the circular economy becomes the foundation of a prosperous and sustainable future. Thank you, and let us begin this transformative journey together. Thank you very much.
Well, thank you very much, Dr. Kari, for that inaugural speech. I wish to invite Jeremy to give...
Charles, before you go to Jeremy, can you ask Mr. Virachari if he wants to speak for 1 minute on his waste to energy plant?
The video.
Mr. Virachari, please.
Mr.
Yeah.
Virachari.
Thank you very much. Can you give me just 2 minutes to complete the video?
Please go ahead.
It's okay. Please do.
Please go ahead. Thank you, Dr. Kare.
Thank you very much. This is the plant which can handle 1,200 tons per day and covering near about 80 ULBs, local urban bodies, and generating 15 megawatt per hour. The plant was commissioned on 21st October 2021 and plant is running uninterruptedly. And the total nearby 80 ULBs, the dumps have been clearly totally cleaned. This is the achievement. This project was executed under public-private partnership under the concept of design, build, finance, operate, own it, and transfer it. Thank you very much for giving me this one. And it is most successful plant on mass incineration process, where Africa also needs such kind of plants many, because 50 of dumps, 19 dumps are in Africa only, which is major dumps. And also I explained in my presentation the impacts of the dump. Thank you very much.
Thank you, Virachari.
Thank you.
Congratulations for your plant operation and for all of information for all that. Virachari will be responsible for conducting one special session on waste to energy plants, whichever are in India and other countries in ICONSW in November, December. Thank you, Virachari, for accepting that. Thank you.
Thank you, Virachari, and all the speakers who have taken us through this inaugural session. I wish to invite Mr. Jeremy to give a small vote of thanks to the inaugural speakers. Kindly, Mr. Jeremy.
Okay, thank you, Charles. We have come to the end of the inaugural session. It's now my humble duty to give a vote of thanks to Professor Michael Koech, Professor Sadan Kumar Ghosh, Mr. Virachari, and Mr. Kare Carstensen for their insightful speeches and sentiments, for helping us set the right tone and mood of sharing our experiences on circular economy, solid waste management, and decarbonization. Fortunately, we have had a good beginning, and hopefully we will have a wonderful and educative ending. Again, on behalf of all the participants, I extend my warm and kind appreciation to the 4 speakers for making time to be with us today. This brings us again to the end of the session. I now hand over the microphone to Ms. Juliana Mwanya to coordinate the next session. Thank you.
Thank you, Jeremy. I'll now be taking us through the keynote session. For our first speaker, we'll have Mr. Devi Rao. He is the director, Davis Laboratory, India. He will be taking us through circular economy in pharmaceutical industry. Welcome, Mr. Devi Rao. Kindly share your camera and your presentation.
Did you read his CV? His CV? Did you read his CV?
Unfortunately, the CV I have is just that brief. That is the director.
Jeremy, can you read the CV of Mr. Rao? Juliana, you must be prepared.
That is the last draft that I have.
Jeremy, can you read it?
Prof, that's the last draft that was prepared. It was not shared.
All right. Okay. Yeah. Over to Davis Rao.
Yes, sir. Thank you much for participation. Since because of the less time, I will directly go into the subject. The subject of today is the industrial waste management, in particular pharmaceutical industry and the chemical industry. We, the generation born in 1940s, are responsible for the destruction that happened in the last 70 years from the environment, from industrial revolution to mechanization to mass production and automation and today's digitization. I have witnessed in my life, I am 80 years now old, studied under kerosene street lamps, lived throughout without electricity at home, went walking to school and everywhere, traveled in wooden buses that ran on steam with burning wood, traveled trains run by coal-fired steam engines, later diesel engines, trains mostly with passenger coaches and now AC berth coaches, traveling in first class cabin planes and now on chartered flights. If I put carbon footprint per kilometer of travel increase in last 70 years, it could cross thousands of times or many more.
By Tuesday
with fuel efficiency and introduction of electrical as well as solar-based, hydrogen-based technologies. I'm here to emphasize importance of controlling the industrial waste, also get the benefit out of it. On a scale of 1 to 10, the municipal waste handling and disposal can be placed at 2. Chemical industrial waste handling and disposal is placed at 10. The protection from the chemical Z category security that you provide to a head of a state. I hope the present handling of this industrial waste, I hope to present on the 13th ICOM SWM in December in detail. You are free to contact me for any query. Happy to share my findings. Back to today's topic of industrial waste. My journey, last 30 years running the industry, leading it to TQM, Total Quality Management, taught me that the survival and existence of the industry with sustainable benefits depend only on how you handle the waste management. Many a time you cannot achieve zero waste, but certainly minimize it and make more valuable recovery from it. If you take care of environment, environment will take care of you. This is what proved for us at Divis. The waste produced in industrial activity, which includes any material that is rendered useless during the manufacturing process, material with reaction and materials without reaction. For example, items like a plastic or glass or constructional demolition materials, wood, ashes, etc., they have no reaction when you touch them. But materials like solvents, acids, reagents, and their derivatives have their own reactive capability when you handle them. Most of them are highly hazardous and some even lethal, some catch fire, some even explode. Most of the industries just follow use and throw for want of knowledge, technology, and investment. Well-designed waste management in broader sense leads to better environmental protection and moving towards sustainability, and much more important, bring more profits to the industry. Intelligence is that waste, calling waste as a byproduct of great value and in achieving the maximum value recovery. This is the birth of value recovery, circular economy, or life cycle enhancement. Once you remove the word waste and introduce product and byproduct, only two items, both have value in the industry, and many a time the waste, so-called, the byproduct, so-called waste, is much more valued than the product itself. Naturally, value recovery becomes a major subject involving 13R, etc., and many more tools. The tools applied for better byproduct management or value recovery are 13R principles, circular economy, life cycle enhancement, zero waste, zero liquid discharge. In our company, these actions are measured and certified by global declared greenhouse gas emissions, quantified carbon footprint quantities. All are presented in annual reports, BRSRs, and many more actions under responsible care, all leading to environmental protection and lowering global warming. All the above and many more activities are finally covered under what is called TQM, Total Quality Management, and waste management is only a portion of it. Value recovery is the backbone of circular economy, resulting in lowest cost of produce, the desired of producing the desired product of
Mr.
high
Rao,
quality.
Mr. Rao,
Yes,
Mr.
sir.
Rao, your PPT is not moving.
Pardon?
Your PPT, your PowerPoint presentation is not moving.
I'm sorry.
Stand still on the first page.
Is it moving, sir?
No.
No problem.
What you can do is you close it and again open, share.
Okay. It is moving on my screen. Do you see that, sir, now?
Yeah, now move it.
Is it moving now?
No. Can you go to slideshow?
Okay. So I'll go by slide.
Yeah, now it's moving. Now it's moving.
Yes, sir, it's moving.
Ah,
Yeah, okay. I'll come to
Yeah,
that.
Well,
I'll come to this of what I call anything in an industry, we only call product which we manufacture and sell. The balance, what comes out, instead of calling it waste, we call byproduct. Both of them have values and you need to value them correctly. Many a time, the so-called byproduct value recovery becomes a major subject involving several tools. The various tools applied are 13 R principles, circular economy, life cycle enhancement, zero waste, zero liquid discharge, etc. In our company, these actions are measured continuously and certified and globally declared greenhouse gas emissions as well as the carbon footprint. All are presented in annual reports, business reports, many more actions under responsible care, all leading to the environmental protection and lowering the global warming. All the above and many more activities are finally covered under called TQM, a total quality management, and waste management is only a part of a portion of it. The importance of the industrial waste, in particular the chemical industry, with a specific alert on pesticide industry as well as the drug manufacturing industry, which we handle. In order of 1 to 10, the polluting industries, if agricultural product can be placed at 1, the pesticides and bulk industries are placed beyond 10. Now you know the importance of handling such hazardous waste. If you do not take care, they are capable of destroying soil, groundwater, and surface water to the whole community. These resources will not be suitable or usable by the next even the next generation. Air pollution to the health of living inhabitants, animals, and human beings, very serious. How this damage happen? Toxic waste without adequate treatment is released to air, water, and soil, sometimes by ignorance, many a times irresponsibility. It must go through thorough checks before it is permitted. In our industry, for example, at Divis, we go through stringent checks and clearances on our liquid discharge that permitted to discharge to the ocean after treatment. The checks by the government are so stringent that can be compared to checks on a terrorist entering on a boarding of a plane. Go through a lot of governmental approvals, initial studies, impact assessments, environmental clearances, etc. by several departments like Pollution Control Board Department, Central Pollution Control Board, Ministry of Environment and Forest, etc. Besides, continuous monitoring reports and reviews take place. For example, each release of the wastewater, treated wastewater to the ocean, several checks that include but not limited to cameras, complete quality check, lock and key system, upload to the web continuously, metering pumps, the release in presence, frequent checks, and the air and water. Once you remove the word waste from the bike and replace it by product of great value, now the industry treats so-called waste with a great respect. Many a time, the byproduct that you see as solid, liquid, and gas is more valuable. Besides, the byproduct that you see, there is a lot that is not seen. That is also a waste. Total quality management calls for addressing this very carefully. Naturally, value recovery becomes the major subject involving several actions like 13R. Out of thousands of actions taken in our industry on value recovery, I will present here only a very few to show how value recovery is achieved and the benefit to the industry. Hydrogen, MVPS, water recycling, power reductions, heat recoveries, cool recoveries, and major recoveries of waste that are seen and waste that is not seen. Now, for example, we used to have 500 cylinders per day usage, and handling of 500 cylinders The problems of ergonomics, safety and all is known in transportation. We replaced it with a high technological hydrogen plant, what you see here, generation plant that eliminates handling all these problems, where it reduces the carbon footprint from indirect CO2 emission up to 265 tons per annum, mitigation risks, ergonomic risks involved in the cylinder handling, mitigation of risks of transportation and pressurized and various other vessels. The other, if you take here, we had a solvent which required very great stringent requirements of the water content up to 0.2%. Normal distillations cannot do that. We need to go and get a specialized system done for this purpose called multiple vapor permeate system costing $3 million. But the recovery of ROI is in just 2 years. That means that every further years of every year what we have an additional value of addition for the profit at $1 million per year. Similarly, solvent recovery systems, we handle several types of solvents in large quantities through distillation columns, reactors, wiped film evaporators, falling film evaporators, reboilers, vent gas condensers. These are all highly specialized technical subjects studied to get the maximum benefit out of them. We remember this knowledge is what I am talking is not just academic, but it is real, handled in the field every day with various studies over years, and it is continuing. Lastly, I close with the remarks for my African friends who have industries that any industrialist who wants to increase his profit by 20%, just follow the time-tested, proven Divi's mantra. Divi's mantra is waste is not a waste, but a byproduct of a great value. Total quality management of this byproduct is so. One, it protects the environment. Two, it provides large profits in terms of circular economy and value recovery. Enhanced safety too. Also conservation of resources, ergonomics, etc. The list is literally endless. Here I am presenting a few of the comparison between municipal waste, domestic waste, industrial waste, and corresponding footprints which can be discussed. I am also presenting in this list the various, when I call 13R, like refuse, reroute, replace, etc., of the 12R cycle. But most important is rethink at each time for a betterment. The other same 13R is produced over here, what they are. When you follow all these things, finally what is left is a small percentage that goes for a landfill with the lowest carbon. Last but not the least, if you see what benefits we had by doing the circular economy and waste management at our company, is the energy conservations of 12.5 million kilowatts. Water conserved is 32,000 liters per year. Coal conserved 3.5 million kgs. Nitrogen 1.8 million meter cubes. GHG reduction 17 million. Reduction of raw materials 24 million kgs. Waste minimization of 140,000 kiloliters, etc. These are very valuable figures, and coming year by year, every year, when you handle your waste properly. How this is possible? It is only possible to meticulously handling the total quality management of the waste to be generated from the company. And what it shows, these figures are each year, how many types of projects we undertake. Small, some of them are small, some of them are big, but they are studied meticulously. 778 different projects of waste management carried out in the company during the year of 2021, 879 during 21-22, 768 during 22-23. Such continual studies improve, makes the waste management to a bare minimum carbon footprint, and you will enjoy simultaneously also huge profits. Gentlemen, I have a lot to talk. I can go into details of several projects, but time is limited now. I thank you very much for the opportunity. I thank Bosch for the opportunity. Look forward for the 13th ICON SWM in Mumbai. If you have any queries, always you can call me now or you can put it later on. Thank you very much for the opportunity, Mr. Bosch.
Thank you so much, Mr. Devi Rao, for your insightful presentation and sharing your experience in the pharmaceutical industry waste management. I now wish to introduce our next speaker, who is Dr. Jason Davis and Dr. Srini Pillay in absentia. Dr. Jason Davis works in the Department of Public Management and Economics, Durban University of Technology. His research interests are in education gaming, in economics, development economics, resource economics, specifically water and sustainable entrepreneurship. Welcome, Dr. Jason Davis, to share your presentation. You may unmute your mic and share your screen. Thank you.
Have you seen Juliana? He is here.
Pardon, Professor?
Have you checked whether he is here or not?
Dr. Jason?
Yeah.
I'm not sure. I'm not sure. I've not seen the list of participants.
Jason, are you here? Satyendra, can you check whether Jason is here or not? But meantime, Juliana, yeah.
I will check.
Satyendra, yeah, please check. And
no, he's not here.
so Juliana, you can switch over to the next speaker. And meantime, Satyendra, if you can just mail him.
Yeah.
So thank you. I'll introduce our next speaker, who is Professor Sadhan Kumar Ghosh, the Director General, Sustainable Development and Circular Economy Research Center, ISWMAW. He is the former head of faculty, engineering faculty, sorry. He is the former head of Dean of Faculty, Jadapur University. He is internationally known for his research on waste management and green manufacturing, with more than 250 publications and principal investigator of 35 national and international funded research projects. His significant contribution in promoting circular economy in collaborative research in 40 countries is praiseworthy. He is involved in policy making committee, standard development and circular economy in small and medium-sized enterprises, and is a member of International Organization of Standardization Technical Committee, that is ISO-TC. I now request Professor Sadhan Ghosh, founder, president, ISWMAW, to deliver his opening speech. I request him to deliver the keynote speech on circular economy and decarbonization and waste management in global perspective.
Thank you, Juliana. Thank you, Juliana. And thank you very much for your introduction. I will today try to make people understand the collaboration and the correlation among the decarbonization, circular economy, and waste management. You know, these three components are a very, very important component with respect to our survival, our sustainable development is concerned. So that's why I like to mention these three components. For our sustainable development goal, we need to have focus on some of the issues. I like to mention those, if we don't have a very effective legislation and the policy instruments, and that to be implemented properly, then only there is a potential for success towards sustainable development goal. So like in India, we have number of legislations which have been enacted in near future and also in the past, but the legislation will be effective if the legislations are revised at a certain periodicity, because the needs are changing, the land use is changing, the requirements are changing, and the international scenario is changing. On the basis of that, the legislation must be made smarter so that it is effective for the nation as well as for the international relationship. With respect to the legislation implementation, which is more important is the public awareness. If people don't know what has to be done, they will go by their own way. And of course, that will be directed by the effective governance from the government. For SDG implementation, we need to have technology and innovation. We need to have the cooperation among the three actors like scientific society, the academician, and the research and development organization. The second one is the government, the local government, national government. And the third is the industry. These three are the very important pillars for the implementation of the legislation and achievement towards sustainable development goal. So that's why triangular cooperation is a very important entity. Then comes the commitment of the citizen. You know that in European country, the commitment of the citizen is much more higher than many other countries in the developed countries and also underdeveloped countries. So commitment of the people in the country plays a very important role with respect to achieving SDGs. And there are two things which are very important. One is the resource conservation, and for the resource conservation, we must focus on the nexus among food, water, energy, and material, because these two are very much correlated. And the other thing which we'll talk about today is decarbonization, circular economy, and waste management. Of course, decarbonization, circular economy, and waste management are very much related to each of the nexus component, food, water, energy, and material, which are also related to the day-to-day activity of each of the citizens of a particular nation. So what is decarbonization and why we are bothering? So if we look into these three graphs, you will find that day by day, the temperature, the global mean temperature, as well as the average national temperature is increasing. Like if I consider for my city, Kolkata, then this year we have been facing a big summer, like a lot of temperature rise in this for last couple of weeks. We have been, the temperature is reached around 40 to 44 degrees Celsius. Whereas in previous years, we did not experience this temperature. And today only the rain started, while in previous years, the rain started at least 1 or 2 weeks ago. So this is a fundamental problem for which we need to decarbonize. I'll come. What is decarbonization? And you know that we have to keep our planet cooler. Like if it warms more than 1.5 degrees Celsius above the pre-industrialization level, and then it is really a problem. And to combat with this situation, we have set a goal to achieve net zero. But what is net zero? We know that global, I mean, we know that the carbon emission, we know carbon dioxide, and we know that greenhouse gases. These are all problem for the society. These are all problem for the environment. So all GHG emission produced by any country, state, city, or company, it should be counterbalanced by equal amount of emission that to reduce or eliminate. So in that way, it doesn't mean that the emission will be zero, but there should be a balance of the emission as well as reduction of the carbon emission. So in that way, we have number of tools which we have developed in near future. I'll come back to that. And you know that one very important thing is carbon dioxide emission, it needs to fall 45% of the 2010 level by 2030. And we have already taken some targets and measures in different countries, and we have set a net zero target by 2050. And nearly 136 countries in COP26, and we have every year COP26, COP27, we have taken a pledge that nearly half of the those countries which are responsible for nearly half of the global emission, they aim for reduction of the emission and reaching the net zero by 2050 or beyond. Like for India, we have taken the target of 2070. Now, you know that decarbonization, in a very simple word, is reducing the carbon emission, reducing the GHG emission. So how it is possible? So there are 5 pillars we identify. One is the zero carbon electricity. Like what is zero carbon electricity? We can go for wind, solar, hydro, waste to energy, and carbon sequestration, geothermal, and many other. So instead of going for fossil fuel, using fossil fuel, we can go for this green electricity or zero carbon electricity. The second is sustainable land use and agriculture, like deforestation, and we have to restore the degradation of the land, and plant-based protein diets. And the third thing is that in the globe, there is a rapid change in the mode of transportation. What we are doing, we're going for the EV, electric vehicles. We are going for the heat pumps, induction heating, and many more things. The building, those are all green buildings. We are making green buildings. We are going for the intelligent building. So these are areas where we can reduce the carbon emission. Then use of synthetic fuels and the energy efficiency by redesigning, selection of the material, and changing the behavior. So these are some of the areas by which, or some of the areas where we must put our own focus for decarbonization. And there are pathways to net zero. There are a number of, the areas which we have already mentioned. And the other thing is that some industry who are emitting more carbon, and the other industry who is reducing the carbon emission, then there is a trade-off of the carbon emission. So we call sometimes the carbon credit. So in that way, carbon offset is funding a carbon reduction project where the carbon removal would not occur without the funding, and carbon credit today has become a business for some of the industries. So that is not bad. But thing is that ultimately, whether it is carbon credits, carbon offset, or any other, the reduction of carbon emission is taking place. And there are some countries, I was telling that 136 countries, you know that the Finland is very, they are well ahead of other countries. They have taken a set of 2035 to reach net zero, like Iceland, Australia by 2040, Germany and Sweden by 2045, and many other countries, including USA, taken as 2017. China, Russia, Saudi Arabia, Brazil, and few other countries, 2060, and India has taken 2070. But more importantly, the nations have taken an oath and they have mandated that we have to go for the net zero. And this net zero is through decarbonization. We have to reduce the carbon reduction. We have to reduce the emission level, and that should be the focus of not only the nation, but for each of the citizen in the world. So, you know that for reduction of the carbon emission, we must know how much I am emitting. So in that way, there is a protocol. We all know that there is scope 1, scope 2, and scope 3 protocol. I am not going into detail of that, just to show, just to create awareness that we have to reduce the scope 1, scope 2, and scope 3. The scope 1 is direct. That is easier to reduce the carbon emission. There are some activities where your car, your generation, burning of the fossil fuel inside your factory, and the electricity which you're using, but most importantly, the indirect scope 3 and scope 2, those are many more, and your focus on this indirect emission reduction should be also more, because you are, it is not very easy, but it is complicated, whereas it is also contributing to your emission level. And you know that there are 15 areas of transformation, how we can reduce our carbon emission, or rather the decarbonization. And the major areas are electricity, transport, agriculture, forest and land use, building, industry, and the waste management. And I'll share this slide, but most importantly, there are 15 transformation areas. You will find that if you consider a specific transformation area, it is very easy to take some action with some target. Like say, if I consider the transformation 4, replace diesel and gasoline passenger vehicle with electric and zero emission vehicle. If I talk about transformation 9, achieve highest possible energy efficiency for building, shell, and appliances. So in that way, we have to focus on each of the transformation area, and accordingly we have to reduce the carbon emission, or rather the decarbonization. So there are a number of aspects. One is the innovation, the zero waste. I mean, you know that zero waste doesn't mean that we will generate zero waste, but thing is that we have to tend towards zero waste. There will be waste from different processes, different activities, but we have to focus on first by redesigning or remanufacturing or changing the materials and changing the behaviors. We have to reduce the waste. Secondly, whatever waste we are generating, we have to utilize that by recycling and others. And so the inert should be less. That means we have to go for zero landfill. So if we reduce the zero waste through waste management, we can achieve this zero landfill. And if there is a zero landfill, then there is a change in the land use pattern. So there is a huge burning of fossil fuel, as well as there are a number of, like say, biomass. Biomass burning is a big issue with respect to the pollution is concerned. So here the carbon emission is more. So this is also a part of decarbonization, that we have to reduce the burning or zero burning so that our decarbonization aspects become more and more. Then the zero pollution. We have again decarbonization with respect to the pollution to air is concerned, emission to air is concerned. pollution to land and water, then again it is a point of contamination and also the waste management. And decarbonization, we have to reduce the carbon emission, and ultimately the circular economy. This helps in reduction of the extraction of natural resources. You know that all these things are happening because we are extracting more and more natural resources. And natural resources, if we reduce the use of material, if we reduce the consumption, if we enhance the recircularity of the material, then ultimately the reduction, extraction of the natural resources will be reduced. And this brings into the circular economy. You know that I have given a definition of the circular economy, and from here we can see that EPCD2, extract, produce, consume, dispose, and deplete. I mean, we are taking the material, then we are producing something, we are consuming that particular product, then at the end of the life cycle, we are disposing it and giving it to the landfill site that will deplete. So instead of depleting this resource, what we have to do is we have to achieve the zero waste by resource conservation. And what are the resources? It can be energy, it can be material, it can be any other thing, and that has to be recovered. So at the end of the life cycle of a particular product for its intended use, we have to make sure that that particular material can be used as an input material to a second process. So if a second process can be started with the waste material, that means it can generate production, it can generate manufacturing, it can generate employment, it can generate economy, and ultimately this will reduce the extraction rate of the natural resources, as well as this will help in developing the sustainable environment. So this is the circular economy.
Excuse me, Professor.
Yeah, how much time I have?
You should be actually concluding. So we'll give you 2 more minutes to conclude.
Okay, so in that way, this circular economy helps in reducing emission. That means if we go for circular economy, then it is a waste management. And on the other hand, it helps in decarbonization. What I want to establish that this is a 3-pronged approach. If you go for circular economy, it will help in waste management. On the other hand, it will help in decarbonization process. So this is very important in today's world, that go for circular economy and achieve decarbonization, achieve waste management. And this is one of my models. I'm not going into the detail of that, but in India, we are taking lead in a lot of circular economy activity, which in turn helps us in economy generation and waste management. So each other, like construction and demolition waste, we are taking it to the building material manufacturing. We are taking the dry waste and non-recyclable plastics into the cement manufacturing. We are taking the reclaimed wood for different other materials manufacturing. We are taking paper for manufacturing different secondary raw material. So in that way, everything which is waste, we are in India manufacturing some other thing, and this helps in reduction of the carbon emission as well as generation of the employment. This is another point which I like to mention, that we need to have the rainwater harvesting for recharging our water, because in many of the, in India, major part in India is there that we have to struggle and we have to walk 15 to 20 kilometers to collect our drinking water. So in that way, this type of recharging will definitely help in sustainable environment. So with this, I will finish it, but more importantly for each of you, whenever you are generating waste, please segregate the waste and add value to the waste. Like in India, we are segregating in 4 or 5, like wet, biodegradable, dry, recyclable. This is domestic hazardous waste, construction and demolition waste, horticulture and garden waste. So in that way, everybody must separate the waste. And if you separate the waste, each of the waste will have a added value. Number of technologies we are utilizing, We have number of rules. This is Swachh Sarvekshan, a very important activity with respect to the circular economy and waste management. And one thing, all our waste management rules are now based on circular economy and resource efficiency, including the 5R: reduce, reuse, recover, recycle, and remanufacture. So I'll just show some of the photographs. These are all technology we are utilizing. And these are the photographs of how people are now activated towards a better, effective waste management. See, this is my research team for seeing the co-processing from the different waste. This is one of my machine I have innovated in 2004. This waste plastic into different products, eco-friendly, and I got a patent for this in 2007. And this is a biomedical waste treatment in India. This is a co-processing in the cement plant for all the types of waste. And this is a biomining. All the legacy waste, we are converting it into the RDF, refuse derived fuel, and other useful material. And these are some of the systems, material recovery facilities. These are all I have taken from one of our city, Indore, which is the cleanest city in India for last 5 years. Biomethanation plants, construction and demolition recycling plants. And we are now 67% recycling the generated waste. So we are trying to achieve around 75 to 80% in next couple of years' time. And with this, I must thank all of you for your patient hearing. And thank you very much. Over to Juliana.
Thank you very much, Professor Ghosh, for your insightful presentation. It's really opened up our minds on what needs to be done to achieve zero carbon emissions and sustainability. I would like to now invite our next keynote speaker. And the next address will be by Dr. Vegan Subriyaman. He is the head environmental health at the team environmental health team at International Center of Insect Psychology and Ecology, Nairobi, Kenya. Dr. Subriyaman heads the environmental health team at ISIPE with over 17 years of research experience in IPM, biopesticides, and edible insects in Africa. In 2020, he was awarded the prestigious award, that is the Curtis Bergfrost Food Planet Prize 2020, in the Insect for Food, Feed, and Other Uses program of ISIPE. He has mentored 4 postgraduate researchers, 12 PhD, and 8 master's degree scholars. Welcome, Dr. Subriyaman. Kindly share your screen and unmute.
Good morning, everyone. I'm just trying to put my presentation on the presentation mode. You can just let me know if you're able to get it on the presentation mode. 1 minute.
You can go for full screen.
Yeah, I'll go for that.
At the bottom there,
fine?
zooming button there.
Good.
You're able to see, yeah? Okay, fine. Good morning, everyone, and thanks, Juliana, for the introduction. My name is Subramanian Sevan. I head the environment health team at the International Center for Insect Physiology and Ecology, based in Kasarani, Nairobi. And the topic that I'm going to present today is on insect recycling of organic waste for a circular economy and One Health. We heard a lot about the recycling requirements in circular economy from Professor Ghosh. I'll give some few of our technology that we're developing, especially to recycle organic waste. Before going into my topic, I'll just introduce my organization as a Center of Excellence in Africa for research and capacity building in insect science and its application. an intergovernmental organization with charter signed by 13 countries, and we have more than 571 staffs belonging to 30 nationalities. We do a lot of capacity building. At any point of time, we have around 150 to 180 graduate students annually. And we are a more than 50 years old organization. And this institute was started off by a visionary entomologist from Kenya, Professor Udiambo, followed by the World Food Planet Prize, Food Prize winner Hans Seren and Christian Burgomeister. And currently, we are headed by Dr. Segenet Kelemu, leading molecular ecologist, molecular biologist from Ethiopia. One of the major challenges that we have been discussing currently is on the waste generation. And as one of the presenter clearly indicated, Sub-Saharan Africa produces around 125 million tons of municipal solid waste, of which around 55 to 60% are organic in nature. If you look at the quantity of per capita quantity of organic waste produced, many of the countries are still lower than the global average. But in terms of the population, we still do produce a lot of municipal solid waste, especially in the urban environments. Like in East Africa, we have around 900,000 tons of waste produced by Tanzania, followed by Uganda and other countries, as you might see here in this report from the World Bank, water waste too. The other major challenge that we also face in Africa is nutrient deficiencies. You can clearly see that you have the pictures of vegetable consumption. The global average that is recommended is around 400 kilograms per capita per year. But most of the African countries, we are consuming less than that, much less than that, 7 to 31. The largest one is 193, which is half of the global average. This you can easily correlate with the hidden hunger in Africa. All those orange areas in Africa that presents nutritional deficiencies as found out by the prevalence of anemia and preschool age children being malnourished. As much as we are talking about nutrient deficiencies and also the waste generations and things, our cities are also growing. Africa is urbanizing, and with the urbanization, the demand for proteins, especially animal proteins, is rapidly increasing. This is not just in Africa, it is also globally. And we are expecting around 60% increase in the demand for animal proteins. And one of the major components that is increasingly becoming scarce and costly is the feed of the animal proteins, animal feeds. And among the feeds, the protein component of the feed is the costliest component in the feed. So in many places, the increased cost of the feed is actually making livestock productivity little unviable for smaller productions in Africa. But if you look at the proteins that are going into the feed sector, these are the major proteins that are going into the feed sector. Silver cyprinid fish, these are the omenas of Kenya. Soybean, which is largely imported into Africa. Production in Africa is much less. Sunflower seeds and cotton seeds. And you all will agree with me that most of these proteins can also be useful proteins for human consumption, which are currently going into the feed sector. Clearly, there is a competition between the protein demand for human beings and also for the livestock, which has to be broken. And in this space, we are looking at bringing in insects, which are capable of recycling organic waste, a lot of different organic waste. They also, as they recycle the organic waste, they build biomass, which are largely protein and fats in nature, and which can contribute into the feed sector, thereby breaking this deadlock between human and animal protein needs. And in that space, one of the insects that is catching up the attention of many around the world, and including in Africa, is the black soldier flies. What you see here belongs to the Stratiomidae family. Insect consumption is not new to Africa. This is just a map of where insects have been consumed directly as human food. And clearly, there are hotspots like Congo and Central African countries are hotspots for insect consumption. And in Kenya, the western part of Kenya, insect consumption is traditional, especially termites, and also in Uganda, around the lakes, and in the coastal regions of Kenya, insect consumption is common. Globally, there are more than 1,100 edible insect species that are consumed by over 2 billion people. Most of us, we think that, okay, insect consumption is basically for people who don't find good food to eat, maize or rice or whatever it might be. But I think I would like to change the perception there, where insects are a delicacy. They're available. For instance, 1 kg of termites, which is normally harvested in the wild, sells for close to 10 euros in Kenya, in the Western Kenya. And Raspolia deferens is a longhorn grasshopper, which sells for around $2.8 per kilogram, which is much higher than the other proteins. It also provides employment to women and youth, where they collect and sell them in the market, which needs to be streamlined much better. Why insects? It's not just the delicacy. This is just an analysis of the protein content of various insects and plant proteins and animal proteins. And then we especially for the black soldier flies, rad on different waste medias, and you clearly see that the black soldier fly protein is much higher than the plant proteins, and in some cases they are also comparable with animal proteins that are available. Apart from the proteins, insects are also rich in iron and also in zinc. Iron definitely required for addressing issues of anemia, and also zinc definitely required for addressing issues of immune priming or against diseases, which we clearly understood during the COVID outbreak that we had. This is the life cycle of the black soldier flies. It starts off like an adult. It lays eggs on near the waist, and maggots comes out and they survive for around 13 to 18 days. And the maggots pupate in 7 to 10 days, according to the temperature conditions that are there. What we have done in SAP is we have optimized the waste substrates that needs to be that can provide you with good production of black soldier flies, effective recycling. We have combined various organic waste that is available, and we find that there are some combinations of organic waste, especially those with molasses, and also the brewer waste are very good in terms of recycling by black soldier flies. But apart from that, there are many people recycling human waste, market waste, hotel industry waste, which are organic in nature, and food processing or fruit processing waste for production of black soldier flies currently in East Africa. To build capacity, this is a new insect which not many people know how to rear them. So at TCP, we have established a kind of a demonstration facility where anybody can be trained for their entrepreneurship on how best to produce these insects. What you see on your left is the demonstration facility. And what you see on your right are entrepreneurs who have been trained at TCP. Currently, there are more than 2,300 entrepreneurs in East Africa. And in most of these entrepreneurs, they have got some sort of training from SAP. And some of the entrepreneurs have now grown from very small production scales to medium to large scale production scales. So basically, as I said, the production by various entrepreneurs ranges from around 26 to 600 tons, metric tons per year, to 1,320 to 3,600 metric tons per year by certain other large-scale producers. And the map that you see on your right are places where currently black soldier fly is being produced, which is recycling organic waste in East Africa. These are the private sector that is emerging in East Africa with the different production capacities. SAP, during the last 4 or 5 years, from 2016, we have trained more than 57,000 people on black soldier fly farming, and more than 100 plus new SMEs are making money from these insects. The most recent entrant into this business in East Africa is Rwanda, where they're rapidly getting into recycling organic waste with black soldier flies. And also we are currently closely working with Ethiopia to take this technology into Ethiopia, especially for recycling organic waste and for the proteins. The proteins, once the black soldier flies proteins is obtained, we have tried to develop feed formulations. More than 50 different feed formulations have been developed, especially focusing on poultry sector, fish, and also the pig sectors, piggery. And we have also tested the willingness of feed millers to incorporate proteins, insect-based proteins into their feed mills. More than 75% of the feed millers are happy to incorporate insects, but one of the challenges that they always give us is the volume of production needs to match their current production levels, which we are now trying to see how we can Most of the large scale producers are getting close to matching that need, but the small scale producers will need to aggregate their product. Apart from that, we have also discussed with the various producers of fish, poultry, and also pigs. And there's a large amount of interest in adopting insect-based feeds in East Africa currently, especially in Kenya. It's not just the proteins. We are also testing these feed formulations with various sectors. Like this is an indication on what benefit you can get by replacing 20% of your proteins with black soldier fly proteins for layers. What you observed is in normal situation, the layers tends to reduce their production of eggs after 52 weeks. But when you incorporate insect-based proteins, they still continue to produce, as you see in the yellow line on your left. And then the quality of the eggs that is produced in terms of crude protein is also relatively much better than feed without any black soldier fly protein incorporated. What you see on your left, on your right, yeah. It's not just with the poultry. We have also tested it with fish, especially catfish and also tilapias. And clearly, addition of black soldier fly proteins in the feeds is at 50 to 75%, increases the productivity level by 37%, and also increases the crude protein that you can get from the fish. Apart from the proteins, one of the major byproducts that comes out is once the organic waste is recycled, you get frass fertilizers, and these are organic fertilizers which can be used for crop production. And one of the advantages with this fertilizer is it is also rich in chitin. So what we find is the chitin in the frass fertilizer can also contribute as a biopesticide in the soil, reducing, mitigating soil-borne pathogens and nematodes and so on. We tested these insect frass fertilizers to various crops, as you see here on tomatoes, French beans, kales, and maize. And clearly in high-value vegetable crops, the yield increases with the frass fertilizers are quite significant. And also in maize, we are seeing some interesting increases in the yield as compared to the commercial organic fertilizers that are available, and also as compared to some of the NPK fertilizers that are available in the market. The proteins and also the frass fertilizers, one other component which you are now actively researching on is the fat content. When the feed miller wants to incorporate the insect proteins, he has to extract the fat, otherwise the feed gets spoiled. But this oil which is extracted out, or the fat that is extracted out, can be interesting industrial products because they are rich in various nutrients and they differ with different species. And according to the nutrient levels of the unsaturated fatty acids or saturated fatty acids, you can identify different industrial uses for it. Some of the oils, like for instance, the oil from the longhorn grasshoppers of Uganda has high levels of omega-3 fatty acids as comparable to any other salmon oil or cod liver oil that we are used to consuming at a higher price from imported markets. So these are the...
Dr. Sevgan, I don't know how much more time do you need to conclude?
I'll just need another 2 to 3 minutes. Yeah, I'll finish it off. Yeah.
I think 2 minutes will be okay.
Perfect. Perfect. So compared to the regular organic omega-3 fatty acids, the insects has a combination of various omega-3 fatty acids, which is good. One of the major changes that contributed to the rapid increase of black soldier fly production in East Africa. This is a description of how it was before 2017 and how it is after 2017. Before 2017, it was largely a traditional affair. Few companies recycling organic waste, but after 2017, it's now becoming a major industry, profit-making venture. And there's clearly the governments in Kenya, Uganda, and Rwanda have been in the forefront to create policies to incorporate insects in the feed, which has actually attracted many private sector companies to start venturing into this and look at it as a business-making opportunity. We have done some socioeconomic impact assessment. This is an ex-ante assessment where what could be the benefit of such kind of recycling of organic waste and replacement of proteins into the poultry sector. And these are the benefits that you can actually achieve for Kenya around. So when we started this ex-ante assessment, we were trying to project at 5 to 50% replacement. Currently, the black soldier flies that is produced in Kenya, if they're accumulated fully, it can contribute around 7 to 9% of the proteins that goes into the poultry sector. Very recently, we are also looking at a circular approach, how the organic waste that is obtained in the villages and rural households can be recycled by insects, fed to animals of the smallholder farmers to provide nutrition to the farmers, and also the organic fast fertilizers, if it can also contribute to the yield increases in a smallholder system. So basically, the circular economy, we are looking at how we can establish it in a smallholder production system or in an area where a large number of smallholders are existing. And this project we recently started, and we will be working on it for the next 3 or 4 years time. And, clearly contributing to the animal health in terms of the protein, plant health in terms of the growth of the plants, environment health, clearing the organic waste, and human health in terms of providing nutrition. So this black soldier fly based recycling is a perfect, could be a perfect circular economy solution for Africa. And the good work that was done by our team here, the Insects for Food and Feed team, fetched us the Food Planet Prize in 2020. It was a team effort, and the award was given for the team, the Insects for Food and Food Feed and Other Uses program. I'm just part of the team. The team is led by Dr. Chrysanthus Tanga, who comes from Cameroon. He's the head of the Insects for Food and Feed program. And we have various scientists with diverse expertise who contribute into the Insects for Food and Feed program in their own expertise. And this program is very much led by the senior management of SAP team, as you see here. I'd like to thank all the donors who have been supporting this program so far. And these are the donors who have been supporting us. And these are the large scale of different core funding partners of SAP who contribute into our work in one or the other way, so on. Yeah. With that, I would like to close my presentation, and I'm happy to take any questions if they are there. Thank you.
So thank you, Dr. Safdan, for the insightful presentation. It was quite informative and interesting on how insects can be used in the circular economy sector. This brings us to the end of the keynote session, and I wish to hand over to Ms. Padma Gunde for coordinating the next session. Meanwhile, I request all participants, should you have any question, kindly post them in a chat box and we'll be able to take them up. Thank you.
Thank you, Juliana. Now we will start technical session 1, that is circular economy and decarbonization. I would like to request Professor Satyendra Upadhyay to chair the session. Dr. Satyendra is the General Management faculty at KG Somaiya Institute of Management and Director of International Relations at Somaiya Vidya Vihar University, Mumbai, India. He has 2 PhDs, one from India and one from China, and MBA in marketing from Mumbai. He has 18 years of industry experience in India, Japan and Asia Pacific, and EMEA. He teaches strategy, international business. His research interest lies in sustainability, circular economy, and internationalization. So I now request Professor Satyendra Upadhyay to chair the session. We will start with the first presentation. The first presentation is by Dr. Stephen Okai, on solid waste management in Uganda. Dr. Stephen, is your internet connectivity okay? I heard that you have a problem. Will you be able to present? Dr. Stephen, will you be able to present? Dr. Stephen?
Yes.
Yeah.
Yes,
Will you be able
I'm
to
hearing.
present?
I'll be able to present. Yes.
Okay, thank you. Dr. Wokai is an accomplished environmental health specialist. He is the former Dean of Faculty of Applied Sciences at Team University in Uganda. Currently, he is lecturer at the Faculty of Science at Kyambogo University. His research interests are clean technology, environmental quality management, solid waste management, wastewater treatment, occupational health and safety, water and sanitation and environmental health management. So now I request Professor Dr. Stephen to present. Kindly unmute and share your presentation. Dr. Stephen, kindly unmute and share your presentation.
Dr. Stephen, can you hear us?
Dr. Stephen?
If you are a host, can you ask him to unmute?
Yeah.
Padma, if there is any, Padma, if there is any problem for the speaker, then you switch over to the next speaker and allow him to go out and come back, and maybe the next one will be there, right?
Yeah.
Don't waste time. Yeah.
And the next presentation is on harnessing waste management and circular economy principles to unlock sustainable energy and agriculture solution in Kenya, a pathway to sustainable development by Ms. Juliana Monia. Juliana Monia is the project coordinator working with the Catholic Diocese in Kutchu and a student at Kenyatta University pursuing Masters in Environmental Studies, Climate Change and Sustainability. Her background is in electrical engineering with a bias in renewable energy. She has experience of 11 years implementing sustainable energy access and environmental projects in rural Kenya. So now I request Juliana to unmute and share your presentation. Your time is 10 minutes. Juliana, kindly unmute yourself.
Thank you, Padma. I hope you're able to see my presentation.
Yes, yes.
So I'll be presenting on harnessing waste management and circular economy principles to unlock sustainable energy and agriculture solution in Kenya as a pathway to sustainable development. So for my first screen, as you can see, these are some of the challenges we are having in Kenya. The first one being a landfill in Nairobi, slum areas, and you can see children passing there. While the second photo on your right is actually in Kitui, which is an upcoming major town, the headquarters of Kitui County. And you can see that even in more modern residential houses, we have poor waste management. The last one is, or rather the third one is in Mombasa, along the oceans, and you can see what is happening in terms of how much you are leaving waste to pollute even our waters, thereby affecting even the sea life. The last photo shows what we hope for as a country and as the global nation. We hope for a more clean environment that is sustainably producing for all of us and feeding us even in the future. So I wanted to ask the first question, and that is, why is waste management and circular economy important for Kenya? And it's because we are facing a major challenge in Kenya, and more so, there are hazard discharging of untreated wastes to the environment. Some of these wastes are from abattoirs. A case example is in 2019, Kitui had to be closed. The Kitui abattoir had to be closed down indefinitely because of the health risk it was posing to the community around. The other thing is the municipal wastes also end up contaminating our water bodies and blocking drainage channels. These posing health risks. Our research in 2020 showed that a total of 5,990 tons of waste were produced in 6 counties, of which 76% of these was produced in Mombasa and Nairobi. We experience water pollution, especially from the municipal waste, the organic wastes from the municipalities and abattoirs that end up in the water bodies, either through rainwater draining them or washing them to our rivers and lakes, and they end up contaminating our water sources, including the groundwater sources through infiltration. Then we also lack waste management infrastructure in most of our counties. And basically, most of our wastes end up in landfills, including those that are collected by the municipalities and collection agencies like the private sector collecting agencies. Additionally, in Kenya, we have very low enforcement regulations of the regulations set up by NEMA, which end up overwhelming the country's ability and capacity to handle waste. There is therefore need for innovation and innovative approaches in waste management and the circular economy that will lead to more benefit for the country and its people. So I did come up with a model that we can think through if we want to have proper waste management, especially for the organic waste, as a pathway for sustainability. And in my model, I thought through a point where all waste that come in, so all waste that come in needs to be sorted from household level or from source. As it comes in, it is collected by private sector or even government agencies that do waste collection. Like for example, in Kitui, we have the Kitui County municipality doing that. So once this waste is collected, we have to have a central location for waste processing. That means this central waste processing station will be able to segregate or designate the organic wastes to go in for further processing, while the other wastes are maybe given out or sold out for other business processing. So in the organic waste sector, which is what I was more interested in, given the risks and the condition it has put our country in, where we are facing a lot of pollution and influence from the organic waste, the sorted waste can now be processed through a biodigester, which from the collection sector, the processing sector can now look at it in the sense that once this waste is brought in, some of the organic waste can be processed directly as feeds for animals, while the remaining, which may be too degraded for use as feeds, can be now passed on for the biodigester to process. The biodigester can now then produce gas, which can be packaged for private use or sale to mostly the informal settlements and rural population who mainly rely on wood fuel and are unable to afford the expensive gas that we are importing from other countries. The byproduct of the biogas, which is the digester, can be further processed, and the water from the digester harvested for recycling, while the digester is further processed through granulation and fortification to provide organic fertilizers. I think that is the other challenge that we are having as Kenya, and we are importing most of our food production in Kenya quite expensive. So by adopting this kind of technology where the byproduct of the biodigester is then further processed to organic fertilizer and fortified to ensure that all the necessary minerals are included in the biofertilizer, and also to ensure that it is cleaned in case of any diseases that may be transferred to the soil. This fertilizer then can be used in our farms enhancing food production for household consumption and even for business in the country. And the process now continues. So the opportunities that are presented through waste management, and especially the organic waste management, is one in conversion of energy to waste, which will reduce the country's reliance on fossil fuel and enhance its resource utilization by improving energy access to the rural areas and the urban poor. Additionally, it presents the opportunity of environmental protection and preservation. Referring to my first slide where I showed different photos, I think the last photo presented a peaceful environment that is more sustainable and able to provide for its people. Additionally, it will help us in climate mitigation, because the early processing of the organic waste will reduce methane emission in the environments from the landfills and enhance energy access to our people, at the same time improve agriculture and our environment through soil improvement and crop production. We also have the opportunity to conserve our resources, more especially our water resource, which is diminishing every day, and we are unable to access clean water even for agriculture. A case example is the level of pollution that is experienced in Athi River, that is suffering from emissions or people leaving their waste, especially municipal waste and sewerages, to flow into Athi River. The same river is the one that is used for irrigation agriculture, especially in the lower parts of Makueni, and the same food consumed by people, making it an health risk to our people. Further, the utilization of biogas for electricity production and also for cooking will preserve our forests, especially in the rural areas where the primary source of heat energy is wood fuel. This kind of model presents us with a lot of economic opportunities, especially creating jobs for the idle youth that come out of school and they have nothing else to do, ending up in crime. At the same time, it's presenting an economic opportunity for the country, since the reduction in importation of fuel from other countries will mean that they'll have more money at their disposal to invest in other important sectors like health and education. Additionally, for sustainability, we'll have improvement in health, since less organic waste that will act as catalysts for biological hazards and pathogens to reproduce will be reduced. Finally, we'll have sustainability in our agricultural sector by reducing the cost of inputs in agriculture sector, since locally produced fertilizer will be cheaper for the farmer as compared to the imports that even have to be subsidized by the country. So what must we do to be able to achieve the implementation of such a model? One is to have a joint effort by the national and the county governments in policy formulation and implementation. This will include setting of standards and targets, and also increasing incentives and holding everyone accountable. This is by ensuring that for like the real estate owners, they're accounting for all the tenants who are staying within their households. Where is their waste going and how is it processed? Additionally, by collaboration among government, NGOs, multilateral and private sector, as well as the community, we'll be able to increase knowledge sharing and encourage social groupings in waste segregation from source, and utilization, as well as investment in the waste sector. I think that one was, we were able to see even in the Indian presentation as having happened, unlike in the Kenyan area. Also, by encouraging the private sector investment in infrastructural development in waste processing, for example, production of gas and packaging it for local use, selling to the local community, and further processing the digester produced from the biogas to form organic fertilizer by granulation and fortification can ensure sustainability of any investor who invests in such a section.
Juliana, can you please conclude in 1 minute?
Yes, I'll be concluding in the next few seconds. So additionally, formation of learning hubs for knowledge exchange, like what we're doing right now, and investing in research through funding of waste management for economic development projects in the country. And then ensuring that waste management is not a divided kind of a process, but rather integration of all sectors into the waste processing, meaning that waste processing can be done from a central point of view. Thank you. So I'll give examples of projects that have been successfully implemented in Kenya. One of them is the Ministry of Environment and UNEP project in Dagoretti, Abata, that is currently processing Abata waste to energy. It's been able to process, or it processes 15 tons daily from 400 animals and has employed over 3,000 workers. We also have Farmers Choice Kenya, which has employed this model to reduce overhead costs in its production line. So I had a few searches that I did over the net, and thank you for listening to me. Thank you.
Thank you, Ms. Juliana Mania. That was very informative presentation on solid waste management, circular economy in Kenya. Thank you so much. Now I request you to stop sharing and mute your microphone. Our next presentation will be on enhancing circular economy to reduce disease burden from industrial air pollution in Kenya by Dr. Mary Kinoti, University of Nairobi. She is a lecturer in environmental and occupational health department of Public and Global Health University of Nairobi. Participated in NEMA's development of environmental impact assessment and audit 2003, and member of technical committee on Nairobi City Council Environmental Outlook 2006. And she is steering committee member of African Research Universities Alliance 2022, and she's currently working with that. Now I request you to deliver your speech. Your time is 10 minutes, and kindly unmute and share your presentation, Dr. Mary.
Padma, check whether our friend Stephen is okay for presentation. Then next presentation, you can invite him.
Yeah, I actually messaged that I will invite in the last of the technical session. By then he will be ready.
Okay, can you see my PowerPoint? Are you able to see my? Yes, okay.
Yes.
My name is Mary Kinoti, and the introduction has already been said. On going through what we have today in the program, been presented so far, I've realized that water waste and gaseous waste have not been very pronounced, and particularly the invisible air pollution. Air pollution is not seen most of the time with our eyes, but it is felt through the diseases people go through. Now, so the objective of today's paper is really to highlight the concern of air pollution, disease burden, and the possible reduction by enhancing circular economy. I have the definitions of circular economy, but more so of industrial air pollution. I'm concentrating or focusing mainly on stationary sources of air pollution. And I was very encouraged by the video that we were shown by one of our colleagues today, because it showed a clean environment where there are incinerators, where there are industries, but still you can see the environment, the air is clean. And some of the reasons, I'm going to enumerate them. Now, the questions I have today is,
Excuse me, Dr. Mary, excuse me, can you please put it in a presentation mode? We are unable
okay.
to, yeah.
Okay. Okay.
Thank you.
Okay, welcome. Okay, so the questions I have today are, what are the air pollutants and their sources? Modes of exposure to cause health problems. Is air pollution a problem in Kenya? How can we reduce air pollution emissions from industries? How can circular economy be enhanced to minimize air pollution? Now, most of the time, this is what we see. And even the visitors, if you're in Nairobi and during the day, you might not see the smoke from the stacks. But as soon as it is 5 o'clock in the evening and you look downtown in the industrial area, this is what you will see. And this is because the owners of the industries are very careful during the day because they know NEMA, the public health officials are all around it to see what is happening. But as soon as it is 5 o'clock, people go home. The officers will go home. And this is the kind of thing you see. Now, what we know about industrial air pollutants? Industrial air pollutant is a product of industrial activity. It's actually a product of development. Industrial air pollution is not equal to waste because from a physical point of view, we know matter is neither destroyed, neither created. It just changes in form. So what we call waste is not waste. It is actually resource. Now, it can be classified in solid and liquid, which we have dealt with so far. We have seen so much work, even here in Kenya, there's a lot of work going on with solid waste management, circular economy with solid waste. But when it is in gaseous form and it escapes in the atmosphere, then it's very difficult to capture. So it should be captured before it can get to the atmosphere. We are exposed through inhalation. And we also know that the circular economy rests majorly on waste reduction, reuse, and the recycling principles. Although now we started with 3, we went to 5, and now I can see some of our colleagues have gone to 13 areas, which is really an improvement. But majorly and fundamentally, it's reduce, reuse, and recycle. Now, these are the gases that are being produced by stationary sources, wherever they are, whether they are incinerators, whether they are manufacturing factories, or whatever. These are the gases, some of them which are very poisonous to us, and we are exposed to them. Now, this is a quick table to show you that quite a number of studies have been done in Nairobi since 1977, for example. This is a Kenyan case study. And it has found out that particulate matter particularly has been well above the WHO levels since then. And even up to today, the levels are still very high. So we can say with confidence that Kenya, yes, the Kenyans, the residents are being exposed to heavy air pollutants. We said this happens through inhalation, and we find out that when this goes through inhalation, it compromises our lungs, it causes the stroke. About 24 cases of stroke that we witnessed today could have been caused by air pollution. Heart diseases, 28% of them. Cancer, 43%. And obstructive pulmonary diseases. Now, not only does air pollution cause respiratory health problems, as we have seen, the stroke, the heart, there's a lot of details in it, but also when mothers are exposed to air pollution, they get affected. It affects exposure of mother to ambient particulates, for example, results in poor pregnancy outcomes, and not only to particulates, even to the sulfur trioxide, nitrogen oxides, and even ozone. They all result to poor pregnancy outcomes, that is low birth weight, preterm, stillbirths, spontaneous abortions, and so on and so forth. So it is important that we see how we deal with this. This was my summary of what I've already shown you, the exposure, the birth weight, the mortality, and the morbidity. I'm looking at it from an epidemiological point of view. Now, to mention that most of epidemiological studies, not many, we have what we say scarce evidence on epidemiological study in Kenya on these diseases, on air pollution. But in other countries, they are very well documented. Now, is there a way of reducing emissions? Because if we can reduce emissions, then we will reduce exposure, then we will reduce the health problems. Yes, we have a lot of devices that can be installed by industries. We have the cyclones, which attract the particulate matter as that air enters, and it goes through a spiral in a cylindrical drum. The particles hit the sides of the drum and fall as solids. Once they're in solids, they are easier to manage. You know, what we are trying to reduce is to have them in gaseous form. So we want to have them in solid form so that we can touch them, we can handle them. So in that case, you find that as the particles drop, the clean air gets dissipated, get into the atmosphere, and we are safer. We have the electrostatic precipitators. They are also there. They attract the particles when the air is coming in. And as it goes out, you find that we have clean air. This is electricity supplied. The machine has to be connected to electricity, and it can remove particulates from industrial pollution. Wet scrubbers also are there, whereby once they are installed, the liquid, then that air goes in, is directed into this cylinder, and also liquid is also directed into it, and the two mix. So if there are gases like sulfur dioxide, nitrogen oxide, which can dissolve in the water, then they dissolve and form an effluent. And the effluent can then
Excuse me,
be...
Dr. Mary, can you
Yes?
please conclude? Your time is up.
Okay. Now, one thing I wanted to mention about that, as mentioned by even Professor Bosch and the others, is that we need, therefore, some of the enhancers, awareness and advocacy for CE to enhance air quality, industrial symbiosis, and the creation of circular value chains. This is because there is no one institution. You know, our colleague from ISIPE has told us where they go to take the insects and where they get the manure. So there has to be some kind of symbiosis between industries that produce waste and that use that waste as a product to produce something else, and then their waste can be used by other people. So it has to be a total ecosystem with more and more industries. Dedicated registration also to CE. In Kenya, we have registration about air pollution, and I have just seen they have the 2022 guidelines on how to apply the registration. So it is still too young to be applied. Maybe by next year we will be seeing some results. Then innovations and the finance and the quick volume. This, we need to get all the stakeholders aligned to the same, to think alike. So we have a lot of work to do. I think, thank you.
Thank you, Dr. Mary. That was very informative on industrial air pollution and circular economy. Now we are moving to the next.
Sorry, I want to correct that I'm Mary. I am MS, not a doctor, please.
Okay, sorry.
Yeah, but thank you. Yeah.
Thank you. Thank you. Yeah. So now we are moving to the next presentation, Green and Circular Economy in Solid Waste Management as a Climate Action by Ms. Grace Ojayo, Assistant Director of Environment, CCNQ, Nairobi City County Government. Ms. Grace is the Assistant Director of Climate Change and Air Quality Monitoring in Nairobi City County Government, Kenya. In her current role, she facilitates green and circular economy initiatives, both in industry and in the local communities. She is also instrumental in coordinating implementation of county sector specific climate actions as outlined in the Nairobi County Climate Action Plan 2020 and 2050. In addition, Ms. Grace is currently supporting the emissions inventory exercise by the Clean Air Catalyst Global Partnership led by World Resources Institute Africa to inform air quality actions in Nairobi City County and beyond. And I now request Ms. Grace to deliver her speech. Your time is 10 minutes, and kindly please unmute and share your presentation. Ms. Grace, are you there?
But also check if she's not there, then Veronica was also supposed to do the presentation from USIU.
Yes.
Mary, can you check with Grace? Mary, can you call her?
I think she is there, sir. She's about to present.
Okay, she is here. She is here. Grace is here.
Yeah, she is there. Grace.
Can you please share your screen, Ms. Grace?
I think she went online. Fine. No, he's there. She is there. She is unmuted, but not able to speak, I guess, some audio issue. Hi, yes. Yeah, you are audible, Grace.
Okay. So, yeah, I'll just go straight into my presentation. Sorry for the delay. Of green and circular economy in solid waste management as climate action. And as you can see, those are the emissions in those are the emissions, greenhouse gas emission sources in the city county. We have, emissions from solid waste management, informal industrial activities, as is self-explanatory from the photos. We also have greenhouse gas inventory that was conducted in 2016. And we are in the process of updating one. It will be released in the course of next month. So it shows that in the emissions in Nairobi City County, transport leads by 45%, then the waste sector by 33%, and the stationary energy by 22%. So in response to this, we have our climate action plan, and I will just highlight two very important ones according to this, relevant to this session. That is transitioning into a circular economy in implementation of circular economy solid waste management approach. And another one is working towards a clean and zero waste city, that is investing in solid waste management, which includes having material recovery facilities and reducing the amount of solid waste from the environment. Those are other climate actions. I will share our climate action plan that may be of interest to the participants. So the background is that over 80% of the waste produced, of the solid waste produced in the city can be processed further, is recyclable, is reusable. And the city has developed a sustainable waste management action plan to help the city actually move from from linear to circular approach in solid waste management. So we are trying to keep the resources in the economic loop through reducing, reusing, and recycling waste, among other activities. Just a background again is that the county got partnership and support from JICA to have our integrated solid waste management plan 2011 to 2030 that sought to divert us from the linear model to the circular model of solid waste management, but it was never implemented as at the set timelines due to various issues in the
we are unable to hear you. I think there is problem with your audio. Even unable to see your presentation.
And in
Ms. Grace, we are unable to see your presentation and also unable to hear you.
She got disconnected, I guess.
So I think she is disconnected.
Padma, let us wait for half a minute. And if she is
Yes.
not come back, then you can go for the next.
Yes.
She has some genuine problem of network from the very beginning.
Yeah. Can anybody contact her? Is that possible?
Mary can connect her, Mary or Jeremy.
So I think she's unable to connect.
Maybe you can go to the next one.
Yeah. So one more presentation is left over in the technical session 1, that is by Dr. Stephen. It was first presentation. Dr. Stephen, will you be able to present now? Dr. Stephen? I think he is also having internet problem. Can you please
that
respond?
Veronica was also there, no? USIU, I think she is
That
there.
is in
Right?
that her presentation is in technical session
Next
2.
session or in this? Someone is in
Technical
USIU.
session 2. She is in technical session 2. We kept it last because it was late.
Okay.
So,
Yeah, Grace has come back.
yeah.
Grace, continue.
Yes, I'll just run through quickly. And this is the current waste flow we have in Nairobi. We are producing 3,000 tons per day, and it's self-explanatory what is collected and dumped openly in the dump site. Some is not collected and illegally dumped in undesignated areas. In my next slide, this is waste characterization in Nairobi. To sort out these issues, we were supported by the UN Habitat to carry out waste characterization in the city. And these are our various components of waste and the amounts therein. That was in 2019. So with this information and in the spirit of evidence-informed planning and decision-making, we got to see the challenges that we may face when we want to implement proper solid waste management. So those are the challenges. You can see minimum waste segregation at source, illegal dumping, inadequate transfer stations, inadequate regulation of actors in the chain. And we are therefore able to come up with 6 key action areas. That is education and awareness, introducing source separation, upgrading collection and transportation logistics, investing in recovery and disposal facilities, then strengthening governance and finance, and sustainable production for waste prevention, supported by the extended producer responsibility regulations that are going to be discussed by MEM, I think, the next or so presenter. So in education and awareness, we have those various, target groups and campaigns and, creating ownership by the community. Then in introducing source separation, those are what is on the screen are our solutions. Then number 3, upgrading collection and transportation logistics, that is gazetting waste collection schedules to have different collection of different kinds of waste or different classes of the solid waste on different days. As you can see, there are days for organic, others recyclable. The days for the organic waste are more because the organic waste is more, and that also is the same case for the other components, as we had seen in our waste characterization exercise a few slides ago. So here is investing in recovery and disposal facilities, because after this waste has been separated from the source, there was the challenge of them being carried using just one truck and being mixed again. So if we have recovery and disposal facilities, that will be easy, and that will now make the separation actually make sense. The county government has embarked on establishment of material recovery facilities in all 17 sub-counties. And those are areas listed. People from other countries may not be able to know where these areas are, but they are familiar to the Kenyans. These material recovery facilities are currently under construction. This one is one of them, and the image on the right is shows how they will look like. That's the design. And this is how we intend our future waste flow to look like, whereby there will be a collection, and instead of...
Excuse me, Ms. Grace, can you please conclude? Your time is up. Yeah, thank you. Yeah, please conclude it. Thanks. You can put concluding words. I just wanted to remind you time. Ms. Grace?
Yeah, she has done with the presentation, I guess.
Okay. One more presentation is left in technical session 1, that is by Dr. Stephen, but he is not responding. So we will go ahead with open house discussion, question answers. You can put your questions in the chat box. And before that, I would request Mr. Satyendra to summarize the session. Thank you.
Yeah, thank you very much, Vanda, and thank you for all the presenting, for listening patiently about the presentation. So we had very nice starting with the when first presenters talks about the Juliana mentioned about like how the circular economy principles can unlock sustainable energy on agriculture solution. So as she very nicely mentioned, like, what are the current, the problem you are seeing it, but the good part is that also she focused on that, what is the expectation of the like green environment are there. So, and the challenges, what we mentioned about the city, I don't know, Marsha, something she mentioned about that. So that was pretty good, interesting when you talk also about that, why the waste management are so important for the Kenya is concerned, when the amount of waste is pretty high. And you also mentioned about nicely about how the 6 country amount goes up to 6,000, around 6,000 tons about that. So one of interesting, Juliana, you mentioned about the model, which was pretty interesting. I think that many of the participants can benefit out of that, how the waste collection and the process further, like how you are using the biogas for the various other purpose. And after the further process, like, how the fertilizer production can be done by that way. So that was a good takeaway from her presentation. Also, Mary, in the next presentation, you highlighted about industrial pollutants and their characteristics around the pollution is concerned. And Mary, you also pretty well highlighted about making the people aware about that industrial pollution, and also sharing with the air pollution concentrations around the Nairobi is concerned. And you are technical with the numbers also you showcase about like how the challenges are there, and what are the devices can be utilized for that, like you mentioned about battery scrubbers kind of things, which can be used for air control, air pollution control device is concerned. And further, the last presentation, the Grace, however, you had a bit of technical glitch, but I think your presentation was pretty interesting when we talk about GHG emission, air pollution sources. And in one slide, I think you mentioned about how the transport is causing like around 40%, 45% of the greenhouse gas emission, followed by the waste and stationary energy is concerned. And also you talked about, how the climate action and supporting action can be taken or adopted by the system. And you, like the previous presenter, also you talked about ENCCG, how the Nairobi is moving from the linear to the circular economy. And I think this presentation helps everyone to understand the problem. And this is probably everyone contribution is required when current waste is around 1,600 ton per day, like around Nairobi, and how this can be reduced by the 3R policy, like, you reduce, refuse, or recycle about that. So thank you for putting all this together. Very nice, thought-provoking, and a lot of learning for everyone. So if anybody has a question, please share your question in the chat box and it can be picked up from there.
Satendra, there is one question in the chat box. Some Anthony, NN.
Okay,
the last one.
To see that I can. I'm not able to see the
Anthony,
message.
are you here? Anthony, are you here? Can you read your question?
Let me unmute it. Circular economy principles can work with finance support by government. It is difficult to segregate waste into different streams. It is to be collected at source. Only problem is to put into proper financial model. See, I seen all the whoever presented all the things circular economy and converted into wood and different products. It can be done everything, but if you put it into financial model in a broad way, nothing is workable.
Like what I would like to add, like in Ambikapur, there is a complete entire waste is generating wealth, is getting monetized about that. So financial model are picking up as policy-wise green bond, as other recommendation, as Peter mentioned. Technology was wise is already there in the place, as Chintan team also mentioned, couple of years in operation. Hope this answer to your question, Steven.
No, just a minute. I want to answer one more thing. Shortly, we are planning to go to Zambia. Lukasa Municipal Corporation also, we are planning to discuss with them for setting up waste energy plant under public-private partnership only. And there we are planning to study, if required, that just now somebody, they mentioned about Nairobi. The daily waste collection in Nairobi is around about 3,000 tons. There also very good potential to set up this mass incineration plant where all the dumps will be totally cleaned. In government of Andhra Pradesh, two processes happening simultaneously. This government of Andhra Pradesh means the south part of India. One, what are the existing dumps are there? They are doing the biomining, means they are cleaning the dumps and generating refuse-derived fuel and sending it to the two waste energy plants. And parallelly, the regular waste, which is called municipal solid waste, that is also coming. This way we can attempt. If the people from Kenya, that Mr. Subramaniam and other people, if they are interested, I am ready to provide the solution with the help of Professor Sadhan Kumar Ghosh.
Thank you. Thank you. It was a nice session. So
before Satyendra, before you pack up, I request my Kenyan friend. So if you are interested to have your wastes converted into business, then I can send my friend to your country and make business with you guys. So who are interested, please let me know so that we can have a consortia of business, and you can have your business with Indian, and you can also reduce your waste burden. Thank you. Over to Satyendra.
Yeah, thank you. That was
there are two more sir,
yes.
Sir, excuse me. There are two more questions in the chat box. One is related to investor by Gilbert, but he is asking that any investor is willing to help startup.
Padma, so what I request, the chat box can be seen by respective speaker, and the respective speaker can write the answer in the chat box. Like I have already written 3-4 answers in the chat box. Okay. So now you pack up for the second session.
Yeah, I think we should close this track over here and move to the next session. So thank you everyone for presenting, all the presenters. Thank you very much. And also those people who responded the question. So over to you, Padma, for proceed with the next
Thanks
session.
to the chair and coordinator.
Yeah, that